Hi guys, and welcome back to the channel. Since getting into machining, having a DRO fitted onto my machines has been a must. This goes from not just the mini lathe but all the way up to my Warco Major GH40. However, until now I've got by without one fitted onto the Harrison M300 and been using these dials that came on the lathe when I first bought it. But in today's video that will all change as we fit a DRO to the lathe. So other than the display you have just seen, this import kit came with two glass scales and a variety of fittings needed to be attached to the lathe. To begin with then, I started by unbolting the Z and X axis dials that have been my old school means of measurement up until now. Carefully, okay, maybe not so carefully, removing the unit. As accurate as these dials are, it has been very easy to lose count when doing long cuts in the past. So having a DRO that does all this is going to come into its own really on this big lathe. Before getting too involved, I wanted to make sure the lathe was nice and clean and free of as much swarf as possible. So I began cleaning down the lathe with a brush and a dustpan just to make sure I got rid of as much as possible. With the help of the workshop apprentice Hetty, we cleared up the last of the chips. Once I was happy that I removed as many chips as possible, then I came in with a bit of WD-40 and just gave everything a light coating to make sure nothing rusted over the time of doing this little install. With the lathe now clean and swarf free, we can start to begin work on installing the DRO. So to begin with then, I wanted to remove the cross slide and tool post just to give better accessibility to the back of the lathe where we're going to be fitting the Z axes for the DRO. So to do this I just removed the gib retaining screw, and then from there we wound the top slide all the way back until the nut had disengaged from the lead screw. Other than fitting a DRO, this gave me a really good chance to look at some of the components on the lathe and make sure they're all in still pretty good working order. So removing the top slide after that is just a case of lifting it off and taking it over to a bench out the way where I can give it a clean down at a slightly later date. But with that out the way now, we've got really good accessibility, and also I can just check the oil ports just to make sure everything is flowing as it should. Luckily for me, on the back of this lathe there's quite a few M6 threaded holes that had been formed when this lathe was first casted, and I'm going to take full advantage of them to install the glass scale along the ways. So unfortunately, after cleaning all these out with a tap, the scale didn't quite line up, so I will have to drill a hole. And to do so I'm using a bit of a crude method here. I'm using the guard to basically mark out where the hole pattern is, and then from there I can take that cover over, laying it across the M6 bolts I've put in to make sure everything is level, and then we can just mark up on the bed of the lathe where the point is that I marked up. So this now gives me a good reference where to drill a hole, and once that hole is drilled I then just have to come back in with an M6 tap and tap that out. Being cast iron, this bed is really easy to run a tap in, so putting an M6 thread in here was no problem at all. And once all that was done, I could then start fitting the scale up just to see how this would sit. So the bit off camera that you can't see here threaded in really easy, and the new hole that I drilled and tapped, I just had to put a washer on there to pull the scale level for the entirety of the bed. Then after that came the really fiddly bits of trying to fit the brackets that came in the kit. One of them seemed to fit really well, the one that clips onto the encoder, but the other one, there's going to be no way of attaching this to the carriage, so I'm going to have to make another bracket up. When making the new mounting bracket, I'm going to be making it from this 10mm mild steel plate that I've got laying around the workshop. To make sure it's going to be the right dimensions, I've taken some measurements off of the extruded aluminium brackets that come with the kit and transferred them over to the mild steel plate. Once I'm happy all those lines are scribed out, I can then go over to the bandsaw and converting it from its horizontal position to its vertical position with this mounting kit that I made up in a previous video, I can begin starting work cutting the plate out and hopefully starting to form the bracket. So being 10mm thick mild steel plate, this was quite a bit of work for my small bandsaw to manage, and it took quite a long time to cut through this steel plate. So resorting to a slightly quicker method, I scribed up with a grinder and tried taking the majority of the meat out of this material by cutting it away with a cut-off wheel. Although this was a slightly messier approach, it got the job done a lot quicker than what it would on the bandsaw. And coming back, I'll just finish it off, parting it off in a controlled manner on the bandsaw. With the mild steel plate now cut out to the desired measurements, I can now head over to my milling machine and start work on that to get the holes exactly where I need them. So to begin with, I need to square this up, and that involves just milling some flat spots on either side of the plate where we've cut it. Although I've tried to be as careful as possible when cutting out, you can never get these cuts perfectly square, so using an end mill here, I'm just cleaning up these surfaces. With that first one done now, I can take it out and deburr it. And then happy that that's deburred, I can then put it back into my vise and tap it down so I know it's flat to the bottom of the vise. And from there it was the same process again of just milling the top flat, and then from there we know that both our sides are going to be parallel to each other, meaning that when we clamp them in the vise in a minute, the clamping force will be equal. So as this bracket doesn't have to be super accurate and the tolerances are quite a lot, I can just scribe the marks on here where I need to drill holes and machine slots in here, and then from there I can just line them up on the milling machine with the tip of a drill. So the scribe mark you see me putting in here is going to be for the 2 bolts that actually hold this to the carriage. And then the elongated slots, which will allow for up and down movement, I can just trace from an existing bracket that I've got laying around from the kit. So like I said, these don't have to be super accurate. The slots are actually M8 and yet the bolts that secure it are M6, so we've got a lot of clearance there. Back over to the milling machine now, and I can start by drilling out some holes and opening them up to be a clearance hole for an M10 bolt. Sending an M5 stub drill down as a pilot hole seems to work really well with this setup, and then after that I can just come back in with another drill to open it up to our final dimensions. And just like that, our mounting bolt holes are all done. Now I need to move over to the slotted grooves, which will be the adjustment in this plate. So bearing in mind how easy this mild steel plate was to drill, I came straight in this time with the 8mm drill bit and plunged it through the work. So these holes on the end that you see now are just clearance holes for the end mill, just to allow it every time it goes down that it's not plunging into new material. So with those clearance holes all now done, we can start the joyous work of going back and forth milling out these slots. So because I'm only using an 8mm end mill, I couldn't go too deep with my depth of cut, so I was sticking to around about 0.5mm here, and because of that it meant I had quite a few passes to do before I could break through the bottom of this 10mm steel. But after what eventually seemed an eternity, I managed to get one slot done, and then it was just a case of moving over to the other one and starting that process all over again. So after all this plate was now finished, it was just a case of deburring that and cleaning it up, ready to install it over back on the lathe. So unfortunately I lost the footage of the next clip, which showed how I squared this plate up, and to do so was quite a simple process really. I put the one bolt in here which you could see, and then using an engineer's square I just butted it up to the side of the steel and rested it on top of the flattest spot on the carriage. That then allowed me to mark up and drill for what would be an M10 thread going into this cast. Again, the drilling and casting operation was very similar to what I'd done earlier on the bed. Being cast, it's quite easy to drill and tap. With those bolt holes now done, I can now bolt up our bracket back onto the carriage and see how we sit for adjustment. So these final adjustments were a little bit finicky. I had to cut down an Allen key to get it to fit in here. But once that bracket was all on there, I can then just double check either end of the glass scale with a feeler gauge that I've got the same gap settings at either end. And luckily for me I did, about 1.5mm gap there, either end. And then with that it was time to test the DRO for the first time. And we have movement. Thanks for watching this video today then guys. I know it's been a little bit of a different style format in the way I've recorded this and the voiceover, so let me know in the comments below if you prefer these type of videos. If not, I'll go back to the original way I do my videos. But for now, that about sums up this video. So we've got the Z axes all sorted now on the lathe DRO, and in the next video I'm going to hopefully get this finished up and crack on with getting the X-axis all done. That's going to have a few more challenges than what the Z-axis has, but I'm sure in a machine shop like this it's all doable. Other than that guys, have a great week and I'll see you next time here in the workshop.